What's up, guys? This is Waleed, and today's problem is the U-tube. So we have this thing that's like U-shaped, and they give us the dimension of it, and they say that there's water. The blue is water, the yellow is some kind of oil. So the first question, what is the absolute pressure in the water at the bottom of the tube? So you can either take it from like this side, or you can take it from this side. Okay, but I'll take the easier one and take the other side, the only water side. So we're gonna use the PGH plus the 1000, 300. That's the absolute pressure on the top that we need to add the atmosphere pressure. Okay, and then this is H1. So for this guy, it's 10 to the third, 9.81 times 0.35 plus 101, 300. And that will give us 104,733.5 Pascal. Okay. Now what's the absolute pressure in the water right at the oil-water interference? So they want it right here. The way to do that is 10 to the third times 9.81 0.35 minus 0.12 plus 101, 300, and that will give us 3556 Pascal. So where did I get this from? They gave us that H2 was 0.12, and we know that the pressure at these points are the same here and here. So I just found the pressure right here at that point. Okay, so 0.35 is the whole distance. I'm minus 0.12, which is from here to here. So I found the water density from here to here, the weight of the water, and then added the pressure of the atmosphere, if that makes sense. Okay. So what is the density of the oil? We'll do the same thing. We know that the pressure at these 2 points, the same thing, are the same. Okay, let me use another color. So here and here has the same pressure. Okay, let me make it in a better way. So here and here have the same pressure. Okay, so going back, oh, what did I do now? So going back to this, what's the density of the oil? So we do 10 to the 3. My brother just called me. So 10 to the 3, 9.81, and then we do 0.35 minus 0.12. So we do the same thing we found in here, and then we're going to equal it to density of the oil times 9.81 times 0.3. 0.3 is the distance from here to here, H3. Okay, so from there you get density of the oil to be 766.66 kilogram per meter cubed. Okay, so now going to this problem. Now they changed some stuff in here, and they changed like the kind of oil, so the density changed, so the height of the water and the oil is going to change because we have different oil change now. All right. So they told us that the whole dimensions are going to be the same. So from here to here, the whole, the heck is happening? So let me clarify. So I gave this D, and then this is H3, and I call this H1. This is going to be the same as H1. So D plus H3 plus H1. H1 is different than the H1 before. So D plus H3 plus H1 plus another H1 from this side, and then plus H3 is going to be equal to the same thing as from the question before, which is 0.35 plus 0.12 plus the 0.3. Okay, so the total here going to come up to 0.77. So here we have D plus, and we have two H3s from here, and H3 is 0.3, so times 2, 0.6 plus 2H1. Okay, so D plus 2H1 is going to be equal to 0.17 meters. Okay, so now let's go to this. Now, what's the absolute pressure in the water at the interference between the water and the oil, the glycerin? So they want it right here. Let me put some red on here. They want it right here. So the way to do that is the P of the oil, GH, and then we get a, let's go H3 in here, and then plus 101, 300. So that will be 10, write the whole thing. So 1261, the density of the oil, times 9.81 times 0.3 plus 101, 300. That will give us 105,011.34 Pascal. Okay, let's close this guy. So now, how much higher is the top of the water in the tube compared to the glycerin? So they want to find the distance D. Okay, so P of the oil, GH3, is going to be equal to P of the water, G D plus H3. Okay, so now P of the, no, we need to find D. So we're gonna solve for D. Okay, let me tell you how I found this guy. So P of the oil, GH3 here, is the same as, here, let me use the red. So here and here have the same pressure. Okay, so we're just finding the distance, or the H for the water for this side, for the left side in here, is D plus H3, which is right here. If you go back to here, and then the distance for here, for the H, for the oil side, is 0.3. Cool. Alright, so let's do the math. And we're solving for D. We can take the G's out. So P of the oil, H3 divided by density of the water, and then minus H3 is going to be equal to D. Some algebra in here. Okay, so we can take the H3 out, and then PO PW minus 1 is going to be equal to D. So for me, D was equal to 0.0783 meters. Sounds good? Oh, we took so much space. So now what's the absolute pressure in the water at the very bottom of the tube? We can find this in like both ways. You can find it either on this side or on that side in here. But I'm going to do the water side. So let's do that. So P water, G. Now the H for the water is going to be D plus H3 plus H1 plus 101, 300. So So 1,000 times 9.81, and then the D is going to be 0.0783 plus H3, which is 0.3 plus 0.04585 plus 101, 300. Okay, so now how I found this guy, which is the H1. This guy is H1 from here. So the way I found it is, remember when we did this equation in here? Okay. So D plus 2H1 equal 0.17. So the H, we have the D. So the D is, what was it, the D? D is this guy. So 0.17 minus 0.0783. And then we divide that by 2. And then from that I got H1 equal to 0.04585. Okay. Alright, so when you do the math for this, you will get 105,460.9. Cool. Alright guys, hope this makes sense. And good luck. Let me know if you have any questions. Bye.